Dear students, I am Ramesh, chemistry faculty from Vidya Mandir Metric Higher Secondary School, Uttangarai. Now, we may discuss a redox reaction. And here we are taking that is redox. Redox here, it is nothing but reduction. It is nothing but reduction. And OX is nothing but oxidation. What is that? Oxidation. So, reduction and oxidation takes place simultaneously, which is known as redox reaction. Now, we may take the natural examples. And when an apple is cut, it turns brown. So, we are taking an apple is cut, then it turns brown. It turns brown. Then, the second example, rusting of iron. Rusting of iron. And the third one, that is burning of LPG gas. Burning of LPG gas. And the fourth one, the metabolic process, carbohydrate is converted into carbon dioxide and water and produces energy. So that it is the metabolic process, that is carbohydrate or maybe the lipid is converted into carbon dioxide and water that produces, that is ATP as an energy molecule. And these are the examples of oxidation. So we are take oxidation. So these are an example of oxidation. Okay. Now, when the oxidation occurs, what will happen? It accompanied a reduction process. So, here all oxidation process accompanied with reduction process, vice versa. With a reduction process. So, all oxidation process accompanied with the reduction process. If the reduction process takes place simultaneously, oxidation is also takes place, so that it is considered as a redox reaction. Now, we may take the classical concepts of oxidation and reduction. Classical concepts of oxidation and the reduction. Now, we may take that oxidation. Now, what is that oxidation? Oxidation is nothing but addition of oxygen. So, here it is addition of oxygen. So, addition of oxygen, which is known as oxidation. For example, we may take Fe is reaction with oxygen and form the Fe2O3. So, iron get oxidized. Then it is converted into Fe2O3. It is the basic process of rusting of iron. So, addition of oxygen to the metal, then it will be get, that is the metal oxide. Now, we may balance it. Here 3 and here it is 2. So, it is 4. So, oxidation is nothing but addition of oxygen. Then, we have take removal of hydrogen. Removal of hydrogen is nothing but oxidation. So, we have take, that is H2S, hydrogen sulfide gas, is reacted with the chlorine and form that is 2HCl and the sulfur. Now, what is that here? From that H2S, we may remove that hydrogen, so we may get that sulfur. So, it is removal of hydrogen. According to classical concept, the reduction is nothing but the reverse of oxidation. So that here it is addition of hydrogen. So, addition of hydrogen is nothing but reduction. Now, we may take that here when sulfur is added with hydrogen and we may get that H2S. So, addition of hydrogen is nothing but reduction. Now, the second process, it is removal of oxygen. So removal of oxygen is also considered as, that is, a reduction. So what is that removal of oxygen? Here it is the example, CuO is reacted with the carbon and form that Cu and that CO. So in cupric oxide, the oxygen is removed and converted into Cu. So here addition of hydrogen and removal of oxygen is nothing but, that is, a reduction process. And here, if the reduction process is accompanied with the oxidation and the oxidation process is accompanied with reduction. Now, we may take that the redox reaction, and the redox reaction is not always accompanied with the oxygen and hydrogen. So, we are taking the electronic concepts. Electronic concepts of oxidation and reduction. And in this electronic concept, we may simply identify, that is, LEOGER, LEOGER. What is it? LEOGER, loss of electron oxidation and gain of electron reduction. So here, that is, LEOGER is nothing but, here the loss of electron is nothing but oxidation. It is oxidation, and gain of electron is nothing but reduction. The chemical examples, the first one, that is Cu becomes Cu2 plus by removal of 2 electron. So loss of electron from the element, then it is nothing but oxidation. So here it is oxidation process. Oxidation process according to electronic concept. Then the reverse we are take, that is Cu2 plus 2 electron become that Cu. So here Cu2 plus ion accept 2 electron and become that copper, and it is the process gain of electron, so that it is nothing but reduction. So addition of oxygen is nothing but oxidation. Removal of hydrogen is nothing but oxidation. And that is loss of electron is nothing but oxidation. The same way for reduction, addition of hydrogen, removal of oxygen and the gain of electron. Now take oxidation number. So oxidation state or oxidation number. Now, by knowing this oxidation state, we may identify the oxidation state of an element. Now, what is that oxidation state? The oxidation state of an element is defined as, it is the imaginary charge present on an element, if all the atoms in a compound is removed with its usual oxidation state. So if all the atoms in a compound is removed from its usual oxidation state, then it is known as the charge which is known as oxidation state. Now we may take a set of rules to predicting that the oxidation state of an element. So we are taking that the rules for determining oxidation state. Rules for determining oxidation state. Okay. So from the rules we may determine the oxidation state of an element in a compound. So the first rule we are taking, the element is present in a native state. So we are taking the element in, that is, a native state. Native state. What is that native state? Is nothing but uncombined state. So element is present in uncombined state. Uncombined state. Then the oxidation state is taken as 0. The oxidation state is taken as 0. It is the first rule. Now we are taking that for an element with a monoatomic ion. So we are taking for monoatomic ion. Monoatomic ion. For a monoatomic ion, the net charge is equal to its oxidation state. So the charge is equal to oxidation state. Oxidation state. For example, we may take Na plus. It is a monoatomic ion. What is the oxidation state? So the oxidation state is equal to plus 1. And if you take Ca2 plus, it is a monoatomic ion. So that the oxidation state is equal to plus 2. So for a monoatomic ion, the net charge is equal to oxidation state. Now we may take the third one. Sum of the oxidation state of all element in a compound is taken as 0. So here sum of oxidation state of all element in a compound is taken as 0. So we may take rules for determining oxidation state. So here, to determining oxidation number, sum of the oxidation state of all atom in a compound is taken as 0. Suppose we are taking here H2SO4. So 2 hydrogen plus 1 and plus 1 into sulfur plus 4 into, that is oxygen, is taken as 0. Now suppose we are taking SO4 2 minus ion, and the oxidation state of an ion is equal to its charges. So here, that is oxidation state of sulfur plus oxidation state of 4 oxygen, and which is equal to minus 2. So here oxidation state of sulfur, 1 sulfur, and oxidation state of 4 oxygen is there. So 4 oxygen, which is equal to its charge present on that ion. Now, so we are taking that hydrogen. And here for hydrogen, in most cases, oxidation of hydrogen is taken as plus 1. So most cases, oxidation state of hydrogen is taken as plus 1. And it has some exception in metal hydride. The oxidation state of hydrogen is taken as minus 1. So in metal hydride. So metal hydride, that is M atom. So oxidation state of hydrogen is taken as minus 1. So hydrogen has 2 oxidation state. Mostly it is plus 1, and in metal hydride it is minus 1. The oxidation state of fluorine is always taken as minus 1, because it has highest electronegative element present in the periodic table. So that it is always minus 1 oxidation state among the halogen. Now we may take that the alkali metals. So alkali metal, what are alkali metal? Lithium, sodium, potassium, rubidium, cesium. All alkali metal, the oxidation state of alkali metal is taken as plus 1. And here the alkaline earth metal, the oxidation state of alkaline earth metal is taken as plus 2. Now we may take, that is for oxygen. So here oxygen has mostly minus 2 as a common oxidation state. So it is mostly oxidation state of oxygen is minus 2. And other than that, In that peroxide, we are taking that peroxide. In a peroxide, the oxidation state of oxygen is -1. Suppose we are taking hydrogen peroxide. And you know that oxidation state of hydrogen is always +1. So here that is 2 into +1 and plus 2x, which is equal to 0. Then what is that? Here 2x, which is equal to, that is -2. So x, which is equal to -1. So in the peroxide, here oxidation state is -1 for oxygen. In superoxide, and example of superoxide, that is KO2, that is potassium superoxide. Then what is the oxidation state of oxygen? And you know that K is alkali metal, so that it is +1 plus 2x, which is equal to 0. So here 2x, which is equal to -1. So x, which is equal to -1/2. So oxidation state of oxygen in peroxide is -1/2. Then with the fluorine, we are taking, that is OF2. In the compound OF2, what is the oxidation state of oxygen? And you know that the fluorine is always -1 oxidation state. Now it is x plus 2 into -1 is equal to 0. So what is that? Here x, which is equal to +2. So oxidation state of oxygen in OF2 is +2. So for oxygen, there are 4 oxidation state. Mostly it is -2. And in the peroxide, it is -1. And with the superoxide, it is -1/2. With the fluorine, in the case of OF2, it is +2 oxidation state. Now we are taking some examples of oxidation number of some compounds. Here we are taking, that is a CO2. Find out the oxidation state of carbon. Oxidation state of carbon. So we want to find out oxidation state of carbon. It is taken as X plus 2, and it is a normal oxide. So oxygen has -2 oxidation state, which is equal to 0. So sum of the atoms of oxidation state in a compound is taken as 0. Now what is it? Here X -4, which is equal to 0. So X, which is equal to +4. Now while writing the oxidation state, it is important to write the positive sign and the negative sign. And positive sign denotes loss of electron. And the negative sign denotes the gain of electron. So it is always write the positive and the negative sign before the oxidation number. And we are taking the second example. We are taking sulfur dioxide. We want to find out the oxidation state of sulfur. So here it is X and plus 2 into -2, which is equal to 0. So X, which is equal to +4. So here also oxidation state of sulfur in sulfur dioxide as +4. So what is the meaning of it? Sulfur loses 4 electrons while forming the sulfur dioxide gas. We may find out the oxidation state of chromium in Cr2O7 2- ion is nothing but dichromate ion. Now we are taking that here, that is 2x plus 7. Oxidation state of oxygen is -2, which is equal to its charge, which is nothing but -2. So what is it? Here 2x minus 14, which is equal to -2. So 2x to it is 12. Then x, which is equal to +6. So here +6 oxidation state. So in dichromate ion, chromium is in +6 oxidation state. In dichromate ion, chromium loses 6 electron to get dichromate ion. And we are taking the fourth example, that is potassium permanganate, KMnO4. Then find out the oxidation state of manganese. Now we are taking, it is alkali metal. So alkali metal, it has +1 oxidation state. And plus manganese, we are taking that X. and plus 4, it is a normal oxide, so that it has -2 and it is equal to 0. So what is that? Here it is X minus 7 which is equal to 0. So X which is equal to plus 7 oxidation state. So in potassium permanganate, manganese is its maximum oxidation state, that is plus 7. Manganese source plus 2 to plus 7 oxidation state. So in this potassium permanganate, manganese has a maximum oxidation state. That is H2SO4 sulfuric acid. We want to find out the oxidation state of sulfur in sulfuric acid. So what is that? Here hydrogen, it is plus 2 and plus X plus 4 into minus 2 which is equal to 0. So what is that? 2 plus X minus 8 which is equal to 0. So X minus 6 which is equal to 0. So X which is equal to plus 6 oxidation state. So sulfur in sulfuric acid, it has a plus 6 oxidation state. That is, it loses 6 electron and form that H2SO4. So these are the example of oxidation state. By knowing the rules, we may find out the oxidation state of an element in a compound. Thank you.